Java exceptions. Let's first take a look at exception handling. So what are exceptions? An exception is an object that describes an unusual or erroneous situation. Exceptions are thrown by a program and may be caught and handled by another part of the program. A program can be separated into a normal execution flow and an exception execution flow. An error is also represented as an object in Java, but usually represents an unrecoverable situation and should not be caught. Exception handling. Java has a predefined set of exceptions and errors that can occur during execution. A program can deal with an exception in one of three ways. It can ignore it, handle it where it occurs, and handle it in another place in the program. The manner in which an exception is processed is an important design consideration. If an exception is ignored by the program, it will terminate abnormally and produce an appropriate message. That message includes a call stack trace that includes the line on which the exception occurred, and it shows the method call trail that led to the attempted execution of the offending line. Next, let's discuss the try-catch statement. The try-catch statement. To handle an exception in a program, the line that throws the exception is executed within a try block. A try block is followed by one or more catch clauses. Each catch clause has an associated exception type and is called an exception handler. When an exception occurs, processing continues at the first catch clause that matches the exception type. As you can see in the example below, you have a try statement the finally clause. A try statement can have an option clause following the catch clauses, designated by the reserved word finally. The statements in the finally clause are always executed. If no exception is generated, the statements in the finally clause are executed after the statements in the try block complete. If an exception is generated, the statements in the finally clause are executed after the statements in the appropriate catch clause complete. Exception propagation. An exception can be handled at a higher level if it is not appropriate to handle it where it occurs. Exceptions propagate up through the method calling hierarchy until they are caught and handled, or until they reach the level of the main method. A try block that contains a call to a method in which an exception is thrown can be used to catch that exception. Please review the example below. Next, let's discuss exception classes. The exception class hierarchy. Classes that define exceptions are related by inheritance, forming an exception class hierarchy. All error and exception classes are descendants of the throwable class. A programmer can define an exception by extending the exception class or one of its descendants. The parent class uses dependence on how the new exception will be used. Checked exceptions. An exception is either checked or unchecked. A checked exception either must be caught by a method or must be listed in the throws clause of any method that may throw or propagate it. A throws clause is appended to the method header. A compiler will issue an error if a checked exception is not caught or asserted in a throws clause. Unchecked exceptions. An unchecked exception does not require explicit handling, though it could be processed that way. The only unchecked exceptions in Java are objects of type runtime exceptions or any of its descendants. Errors are similar to runtime exception and its descendants in that errors should not be caught, or errors do not require a throw clause. The throw statement. Exceptions are thrown using the throw statement. Usually a throw statement is executed inside an if statement that evaluates a condition to see if the exception should be thrown. Now let's discuss I/O exceptions. So I/O exceptions. Let's take a look at issues related to exceptions in I/O. So a stream is a sequence of bytes that flow from a source to a destination. In a program, we read information from an input stream and write information to an output stream. A program can manage multiple streams simultaneously. Standard I/O. There are three standard input-output streams. You have a standard output defined by system.out, standard input, which is defined by system.in, and a standard error, which is defined by system.err. We use system.out when we execute println statements. System.out and system.error typically represent a particular window on the monitor screen. System.in typically represents keyboard input, which we've used many times with scanner objects. The I/O exception class. Operations performed by some input-output classes may throw an I/O exception. For example, a file might not exist, and even if a file does exist, a program may not be able to find it. The file also may not contain the kind of data expected. An I/O exception is a checked exception. Writing text files. The file writer class represents a text output file, but with minimal support for manipulating data. Therefore, we also rely on print stream objects, which have print and println methods defined for them. To continue with writing text files, we also use the print writer class for advanced internationalization and error checking. We build a class that represents the output file by combining these classes appropriately. Output streams should be closed explicitly.